Here we are graphing a sinusoidal function, namely a cosine function, with a host of transformations embedded within. In this case, we're going to graph over the interval from -90 all the way to 180, so not the entire grid that you see down here, just part of it. And we have a whole bunch of stuff going on here. Now, before we start, we have to make sure that we express this equation in a form that is, we can easily pull out what the transformations are. And this tends to throw some students off, but if you look closely here, you'll see that the 1/2 has not been factored out of the argument over here for cosine. So what I'm going to do is rewrite this as 3 cosine 1/2 x minus 90, because if you divide, if you factor out 1/2 from 45, you end up with 90 degrees, and then I have -1. If you want to see how that works, you can multiply the 1/2 back into the x, which will give you 1/2 x, and you multiply that to the -90, that'll give you -45. So in this way, we can see clearly that our a value is 3, our b value is 1/2, our h value is -90, and our k value is -1. Okay, let's now use this to create our map for the transformations. So I'm going to have x comma y gets mapped to, 1 over b, so that's 1/2, which is going to be equal to 2x, and then minus -90, I'll have plus 90, comma, 3y minus 1. Okay. And I'm going to be using the table of values for cos, so that's the base table. I'm going to have 0, 90, 180, 270, 360. So 0, sorry, that's for sine. Start with 1, 0, -1, 0, 1. I'm going to put these points one at a time into my mapping equation over here to see what my new points are going to be for my graph. Again, if you want, you can always do them one at a time, sketch each graph as you see fit, but I'm going to do it this way here. So what happens to start with the first guy, 0 and 1, when I plug it into this here? So I'm going to get 0, 1 becomes 90, 2. And again, I'm plugging in the 0 here, the 1 over here. I'll let you do the math. I have 90, 0. That's going to become 270, -1. I have 180, -1. That's going to become, what do I have there, 360, 450, -4. And then I have 270, 0. And that's going to become 540, 630, right there, -1. And finally 360, 1 will bring me to 810, whatever, 1 there, I believe 2. Yep. Okay, so let's take a look at this. Got a whole bunch of stuff going on. This looks like it's being stretched out quite a bit by a factor of 2. Let's go to our grid. Okay, so my first point is 90, 2. So 90 and 2. My second point is 270 and -1. My next point after that is 450, which is going to be right at the end, and -4. So it'll be right down here. Now at this point, you could probably figure out that, I'm going to be going off the graph, off the grid here. I don't have 630, I don't have 810, so I'm kind of stuck, except that remember, cosine, it's going to go something like this. Oops. Try smooth. Okay, and then over here, it'll kind of go something like that. So where's that point on the, this side here? Well, between 90 and 270, we have 180 degrees. And if you remember, cosine is symmetrical. Okay, so if I go 180 degrees the other way, that'll give me to -90. And so my point at -90 should be -2. Let me just smooth that out a little bit. So there's our curve. Again, I'm using a lot, just a fraction of it. I'm not actually sketching even one full cycle because I don't have enough space here, but that's okay. The question wants us to sketch everything between -90 and 180, and indeed, that's what I'm doing, and I'm going to have to actually erase some of this. So let's take this. Everything after 180, I can pretty much get rid of. Again, with an eraser, it looks better. Piece of paper. And my graph will end over here at 180. These here I don't need. And I can, oops, erase that again. There we go. And that's it. There's your graph. You've only sketched a fraction of it, but we can answer some questions based on it. The amplitude, I'm going to read these off the equation actually. The amplitude, if you haven't noticed yet, is going to be the 3 in front. The period, okay, is going to be 360 divided by 1/2, or 720. That's why it's so big it doesn't even fit on the screen here. What else do we have? The phase shift, or the horizontal shift. Is going to be 90. And that is going to be 90 to the right. In fact, you notice that the top of our cosine graph over here, usually it starts over here, then goes down. Well, it's just being moved over this way, and it's coming down. So, intuitively, or based on the picture, that looks good. The sinusoidal axis, that will be -1, which is this guy. So axis will have y equals -1. And the phase shift, phase shift, I already did that. What I didn't do was the range. The range. So this function will go, if we look at our y values over here, it'll go as high as 2, and as low as -4. So the range is going to be all real numbers y such that -4 is less than or equal to y, which is less than or equal to 2. Anyway, I think we have stated everything. Amplitude, period, range, sinusoidal axis, phase shift. That has all been put in, and that's our graph. Again, very small section of the full thing, but